Hi guys, so if you have observed the busbar protection circuit scheme carefully in the transfer bus or auxiliary bus bay, you can see these diodes. You can see these kinds of diodes that are placed in the circuit. So today in this video we'll be see what's the purpose of using these diodes in the transfer bus or auxiliary bus bay in the busbar protection scheme. Okay, so to understand that, first to understand that, we'll first see the circuit of a normal bus, or we call it as the main bus. Okay, so in this you can see this is the bus bar output contact, bus bar relay output contact. Okay, when there's a fault in when a fault on any section, okay, so this contact output contact of that bay operates, which in turn operates the 96 relay of that bay. Okay, and at the same time the pulse is extended through bus isolator of that bay. Say if the bus isolator of that bay is closed, then the pulse will be extended to the trip bus of that particular section. Means if this is a bay, say bay 203, then the trip bus then the 96 of the bay 203 will operate, and at the same time the if say the bay 203 is in section 1, then the trip bus of section 1 will operate. Okay, so this is how the tripping works in the main bus protection. Okay, now let's see. Now we'll see what happens in when we transfer a bus or transfer a bay on transfer bus. Okay, so we'll just zoom in this diagram. There are 3 diagrams in this slide. Okay, so in the first one, okay, so first one we have put bay 203 on the transfer bus. So this is the main bus, okay, and this is the transfer bus. All right, and so the current is coming through this bay, okay, and then it is going through this transfer bus transfer bus coupler into the transfer bus, and from there it is going out through this bay 203. All right, so this is how it is. So to take any bay on TBC, what we do is we open its bus isolator, we open its breaker, we close its C isolator, okay, and we close the A isolator, C isolator, and the breaker of the transfer bus coupler. In this way we can put any bus on transfer bus. Okay, so okay, now in this case we will see this case over here. What happens is there's a fault on the transfer bus. What will happen in this case? The current, this will flow in this direction. Okay, yes, but the current which was earlier flowing in this direction will now flow in the opposite direction. Okay, in that way, with the help of the direction, the busbar relay will be able to decide that there is some kind of a fault on transfer bus, and so it will operate its relay. And then what will happen is, okay, so once the fault is identified by the busbar relay, then it gives a command to the 96 relay of transfer bus, and its breaker operate, and now the current won't be flowing into the fault. Okay, now the fault will be isolated. Okay, now you can see this line may still feed the transfer bus fault, but it will get cleared from the remote end. Okay, so in this way we isolate the transfer bus fault. So in the main bus, what we do, all the feeder on that particular section will get tripped, but in the case of transfer bus fault, only the transfer bus coupler breaker will be will get tripped. Okay, will be tripped by the busbar relay, and the own breaker of the bay that is being transferred on the TBC is already open. So the only the trip relay of the transfer bus coupler will operate. Okay, the bus should not operate. Okay, at the same time, if the LBB of this transfer bus coupler relay operates, then the entire main bus should operate, or the bus section in which the transfer bus is connected should operate. So to satisfy both of these conditions, we have to use the diodes over here. Okay, so this is the this is the scheme of the transfer bus, how it should operate. Okay, so what happens is, when there's a fault on the transfer bus, the relay has identified that that there's a fault on the transfer bus, then this output contact of the transfer bus operates. So what it does, it is sends a command pulse. Pulse is extended to the 96 relay of the transfer bus, and the breaker of the 90 of the transfer of the bay of the transfer bus coupler operates. Okay, and so but the trip bus should not operate in this case, because there is only one bay on the transfer bus, and if this the transfer bus coupler is isolated, we have seen in the earlier diagram that if the transfer bus coupler is open, then there will be no source feeding the fault. Okay, so that's the reason the pulse should not go to its trip bus. All right, the pulse should not go to its trip bus, and that's why we use diode in this relay, so that the pulse is not extended in this direction. Okay, but if the LBB of the LBB of the transfer bus coupler relay operates, then it should extend to its 96 relay, and at the same time it will extend to its trip bus. Okay, so that's the reason why we use the diodes in the transfer bus couplers. So now you know why we use diodes in the transfer bus coupler bay or in the busbar protection scheme. Thank you guys. For more such videos, do subscribe to our channel, and also I'll be giving the link to my LinkedIn profile. You can follow and connect me on my LinkedIn profile. Thank you so much, guys.